Okay, hello everybody. Today is October 6th. This is an asynchronous assignment, and it's about interpreting slope and y-intercept when you have a context with your equation, with a linear equation. So kind of our basics of slope and y-intercept, that slope is really the change in y for each x, right? So it's delta y over delta x. And what we'll look at today is what happens when we have variables that have like a name, like they're in the real world. And then the y-intercept is the start or the initial value for that y. Our equations, our linear equations, are really telling a story about y. That's kind of what makes them functions, is really that y is a dependent variable and that's changing, or we're describing it in terms of the independent variable x. So our first example here, we'll start with a graph, and I can see here that along the x-axis is my time in years, and then along the y-axis is the population. And that really what's happening is that I see a line that's really describing what's going on with this population in terms as the years are kind of going along. So that when I start with my, if I look at my y-intercept, there it is right there, kind of with that circle around it. It's the point 0 and 10,000. And what that really means is that at year 0, the population is 10,000. The population is starting at 10,000. Next, we're going to look at the slope. And I can see here, if I go to find another point, to get from 10,000 all the way up here to this next point, 31,000, I'm going to go up 21,000 and over 7 years. So the slope, 21,000 divided by 7, which I can reduce to 3,000 over 1, which means that the population is increasing 3,000 people for every 1 year. If I was to write an equation, I could write it, and I can write it two ways, but I will describe it here as like y equals this 10,000 plus 3,000x. So I'm starting, my initial value is 10,000, and I'm adding 3,000 every year. All right, let's start now here where we have a situation. So imagine we've just hired a Fortnite coach, and the initial online startup cost is $5, and then it costs $5 for every 15 minutes. We're going to graph the situation, the graph of the situation, and then we're going to interpret the slope and y-intercept. So here, my x is going to be the minutes. That's going to change. The minutes are going to determine how much I'm going to pay, and y is going to be my cost. So let's look at the graph here. So along the x-axis is minutes, along the y-axis is cost. I'll start here identifying the y-intercept. There it is, 0, 5. What that really means is for 0 minutes, it costs $5. I just to have the coach, I have to pay $5. Then I have a change. I can look at it two ways. I can make a small triangle, or I can make a large triangle to find that slope. They're equivalent, because I could do 5 over 15, which is the same as 1 over 3. This means that really the cost is going up $1 for every 3 minutes. It's the same as saying $5 for every 15 minutes, but the reduced fraction is better. So then my equation is y equals 5 plus 1/3 x. And that's just a little bit about interpreting slope. We'll do some more practicing of this next week. Everybody, you all have a good day, and I will see you soon.